Hello and welcome to itnodes.in. My name is Vishnu, helping you with your ICND syllabus. In this video, we'll be talking about the great and powerful OSI model. If you come from a computer background, you must have heard about the OSI model, but but to tell you the truth, I've been teaching for some time now, and some of the people who has come from computer background, they don't know the details about the OSI model, right? So don't worry, we'll be getting into the details of the OSI model. We'll be understanding what each layer of the OSI model does. After which, we'll be talking about, hold on, let me just take my pen, mouse pointer as pen, okay. After talking about the OSI model, we'll be talking about the TCP IP model, okay, which is also required for the exam. But if you just want to study one of them, then go with the OSI model, because the OSI model is far more important than TCP IP model. Fine. Okay, so what's an OSI model? An OSI model is a reference model to describe how applications work over a network. So this covers the whole thing. A model which describes how an application communicates over a network. That's what a OSI model is. Okay, and it is described with 7 layers. Okay, it's a layered approach. Fine. So we'll be talking about the different layers of OSI model and what each layer does. Okay. So this definition over here, okay, answers what an OSI model is, but it doesn't answer why we need an OSI model. Right? The answer lies in these 3 points. Fine. One of the main reasons why OSI model is very important is because when a vendor or a developer, okay, they create a product or a software, they should create the software in such a way that it is compatible with other softwares. Some of the sites you might have seen, okay, it is only compatible with Windows Explorer, or it is compatible with Google Chrome and Firefox. Okay, the reason why compatibility issue comes is because people are not following the standard, right? Okay, so following the standard is very important, and OSI model is a standard. And another reason is to help vendors, okay, describe their product. For example, a switch works in layer 2, or a router works in layer 3, or a hub works in layer 1. Okay. And finally, it helps in troubleshooting scenarios. We'll get to how it is useful in troubleshooting scenarios in the end. Okay, end of this video we'll be talking about that. Please note that this is a very important interview question. The reason why I said that is because in most of the interviews that I have attended, the interviewer had asked me this question: how do you troubleshoot a scenario? Okay, so let's look at the OSI model. This is a OSI model. This is a description of the OSI model, and this is a PDU, right? PDU, if I can write properly. Okay, fine. That's PDU, protocol data unit. Okay, and this is the OSI model, OSI. Our interviewer might ask, what are the different layers of the OSI model? You are expected to learn all of this by heart. That's physical, data link, network, transport, session, application, session, presentation, and application. And what you see here is the layer number. So when a person says, what is layer 2? Okay, you are supposed to know that that is data link. Okay, when a person asks what is layer 4, okay, you are supposed to know that that's transport, right? Sometimes people will say that's a layer 8. Okay, the layer 8 is known as the user. Okay, but that's not actually in the original OSI model. Okay. First of all, we have the application, that is layer 7. Okay, what is the application layer? Okay, for example, let's just take Internet Explorer. Okay, there's no internet connection, there's nothing. What you see over there, it will show you the site is not available, or something like that. They'll write, right? That is the application layer. Okay, now the web page that you see in the application layer, okay, it is encoded with HTML. Okay, that is in the presentation layer, right? The application layer is the application that is running on the system. A presentation layer is responsible for encoding, decoding, encryption, and decryption. Okay, fine. And finally, there is session layer. A session layer basically establishes, maintains, and terminates a session. Okay, let me just separate these three. Okay, these three comes in the system side. And as a network engineer, system. Okay, and as a network engineer, these three are the least important. As a network engineer, usually we don't look above these layers, but sometimes we do look, but in most cases we don't. Okay, so what is transport layer? Okay, transport layer basically defines the protocol and the port number which is being used. For example, I'm running a HTTP server. The port number will be 80. This is my website itnodes.in. Okay, um, these are the well-known port numbers. These are the port numbers that you are expected to learn. Okay, not all of them. I have written a bit extra, but if you know all of them, that's well and good. Okay, but most of them are very important, like FTP. Both FTP are 20 or 21. We have SSH, we have telnet, we have SMTP. SMTP, it's not all that important in my opinion. Okay, but some people might ask you about SMTP. We had DNS and DHCP, TFTP. This is HTTP that I said before. That HTTP is, in my opinion, again, POP3 and SNMP is not all that important. For CCNP, BGP is very important. You should know that BGP is TCP port 179. Similarly, SSL, that's 443. So HTTPS runs in 443. Okay. The actual list, this is the actual list. Okay, just it is never ending. Okay, we have well-known port numbers. Look at this, the well-known port numbers that start from 0 to go, yeah, 1023. 0 to 1023 well-known port numbers, and the list doesn't end. Okay, then we have registered ports. Okay, the registered port starts from 1024 to keeps going and keeps going. Yeah, I think it's about to end right now. Yeah, there you go. 61,001. Okay, so you have that many port numbers, but you don't have to memorize all of them. You just need to memorize most of these. And that's a port number that I was talking about, and that's a protocol. Okay, for CCENT, you need to learn two protocols. That's TCP, and UDP. Okay, TCP is known as the reliable protocol, and UDP is not reliable. Okay, it's unreliable protocol. So when do we want to send data unreliably? Whenever we send a data, we want our data to reach the destination. That's why we are sending our data. But there's as I said before, UDP is unreliable. There's no guarantee that our packets will reach the other end. Okay, so when do we use TCP and when do we use UDP? TCP, the way TCP works, okay, is by this is just an overview. We'll be getting into the details of TCP later on. I have two computers, right? The way TCP works is, I'll send a data. First I'm going to send a data. Okay, then this guy will be like, okay, fine, I'm ready for listening the data. Then this guy sends the data. This guy says, okay, I got the data. Then he says, I'm gonna close the connection. And this guy will be like, okay, go ahead and close the connection. That's how TCP works. Okay, UDP on the other hand, A, B, that's the end of my screen. UDP on the other hand will be just like, go ahead, this is my data. Okay, that's no acknowledgement. Okay, A doesn't know whether host B received the data. Fine. So what do you see from here? TCP is slow. Okay, UDP is fast. Okay, that's why people will send data unreliably. For example, when I'm doing voice over IP, okay, or when I'm using video over IP, okay, I'm streaming live video onto the television. Okay, so we don't want the whole video to freeze just because one pixel didn't come. Okay, if the pixel didn't come, we want it to let it go. I don't care about that pixel. Go ahead with the rest of the images. In transport layer, we choose whether the protocol should be TCP or the protocol should be UDP, and also we choose the port number, as I said before. That's the transport layer. And then we have the networking layer. In the networking layer, we basically add the IP address. IP address. IP address is the protocol, okay, of the TCP IP suite. There are other protocols like IPX and SPX and Apple Talk, but currently CCENT, CCNA, CCNP, all of this handled with IPv4 and IPv6. We won't be looking into IPX, SPX and stuff. So after the network layer, we have the data link layer. In the data link layer, the main protocol that we will be working on is the MAC address. There are other protocols like the DELC. We will be studying about DELC, okay, but our main focus is MAC address, okay. And finally, we have the physical layer or the L1 layer. The L1 layer consists of all the physical objects like the NIC card, the cabling, the jack, the electrical signals, anything that's physical that comes under physical layer. In the previous slide, okay, I said OSI model is used for troubleshooting, right? Okay, so how do we use this model for troubleshooting? Okay, if there's a problem, the best practice suggests that you first check other physical components. Okay, you check the NIC card, whether the NIC card is working. You check whether the cable is working. Okay, you check whether the switch is working as a switch. The NIC card of the switch is working. You know, stuff like that. Check the physical components first. If this is okay, then go and check the next one. Okay, so in the data link, the switch is not working properly, for example, or there are two computers here with the same MAC address. Okay, stuff like that will create a problem. If the data link layer is okay, if there's no problem detected with the data link layer, then we go ahead and check the IP address and the equivalent protocols. Okay, that is check whether we have accidentally put the same IP in two computers, or check the routing table in a router, stuff like that. Okay, and then we get into the protocol. Okay, whether the protocol is being blocked by a firewall, or whether the program is using the correct protocol. Okay, I want to go ahead and talk about the PDO now. First of all, our application layer, it creates a data. Now, this is known as a data packet. This is the PDO of the application layer, the presentation layer, and the session layer is called data. Okay, now with the data packet, okay, if I add the protocol, if I add protocol plus port number, then we get segment. Segment. Okay. Okay. So with a segment, this is a segment. With the segment, if I add the IP address, the IP address header, okay, then we get a packet. Okay. And with the packet, this is a packet. With the packet, if I add the layer 2 information, that is the data link layer, that is the source MAC address and the destination MAC address, then I'll get the frame. This is frame. Okay, and finally all of this will get converted to electricity. Okay, this is known as bits. Bit is the most if you haven't seen the previous video, bit is the most basic unit of in the computing world. Okay, so we convert this whole structure into the basic unit and then convert to electricity and let it go through the wire. Okay, that's what I have shown over here. From the application presentation and session, we create a data packet. Okay, from the data, if we add the transport layer information, that is the protocol and the port, if we add protocol and port number to the data packet, it is known as segment. Okay, and to a segment, if we add IP address information, then we get a packet. Okay, if we add MAC address information to a packet, we get frames, and finally we convert this whole structure into bits, okay, and send it through the wire. Okay, so let's assume that my computer, that is 1.0.0.1, okay, this is the IP address of the is the IP address of my computer, and this is the MAC address of my computer. Okay, it's trying to connect to a server which is on my LAN. Okay, the IP address of that server is 1.1.1.1, and the MAC address is b.b. Okay, now this server, okay, it has multiple services running. That is it is a FTP server, TFTP server, okay, HTTP server, HTTPS server, and a telnet server. Okay, now from this computer I open an internet explorer, okay, and I in the address bar I type 1.1.1.1, okay, and when I press enter, what it does is it will create a HTTP request packet. Okay, this is the data that I said before. Okay, the PDU is the data. This data is generated from these three layers. Okay, now with that data we add the protocol and the port numbers. Okay, since we are looking for a web page, okay, the port number is 80, that is the HTTP server. Now if the port number was, for example, 20 or 21, that would be FTP. Okay, if the port number was 443, that would mean I'm trying to contact the HTTPS service. Fine. Also note that I have created a source port within this computer, okay, with the number 4212. This is a randomly generated number. Okay, the computer simply creates a number for its own. Okay, I'll tell you why it is created in a bit. Okay, after this I go ahead and add my IP information. This is known as a packet. Okay, now with this I'll be adding my source MAC and my destination MAC. Okay, and then finally it is converted to bits, and then send it to the wire across send it across the wire to the server. Now the server receives this packet, and then it will start decapsulating the packet. What happened here was encapsulating the packet, because we were adding information. We had that data, then we added our transport layer information, that is the protocol and the port number. Then we added our IP address information, then we added our MAC address information, right? So what we were doing is we are adding information. That's why it's called encapsulating. Okay, and then over here what's happening is we are removing the information. Okay, so when it goes across the wire, okay, first of all, since this computer got the packet, it will check the destination MAC address. Okay, since the destination MAC address is B, it knows that this packet is meant for the server. Okay, so it will further de-encapsulate the packet. Okay, so it removed the MAC address over here. Okay, there's no more MAC address information. It is there in the system's memory, but it has been removed from the packet. Okay, and then it checks the destination IP. Okay, since the destination IP is of the server, it still understands that the packet is meant for the server, and therefore continues decapsulating. Now it sees that it is TCP port 80, so it understands that it is meant for the HTTP server. Okay, and therefore keeps on decapsulating and finally gets into the HTTP request packet. Since the HTTP service got the packet, it will generate a HTTP reply and then resend it back. Now if you look at it carefully, the source port became 80 and the destination port became 4212. Okay, I had said before this computer is generating a random source port. The reason is because when it's receiving a reply, it is expected to get the reply on this port. Okay, the reason why this exists is because imagine you opened an internet browser, and then you in the first tab you open google.com, in the second tab you open yahoo.com, in the third tab you go ahead and open msn.com, right? So when your computer gets the reply, how does the computer know that this packet is for google.com, or this packet is for yahoo.com. Okay, the way they recognize each packet is by the port number. Okay, when you type google.com, they create a port number for it to listen on. Okay, so they go ahead and encapsulate the IP address information in this and the data link information, and finally convert it to bits, send it over the wire, and over here decapsulation process occurs, and finally our computer gets the HTTP reply. Finally, I want to talk about the TCP/IP model. So what is the TCP/IP model? TCP/IP model is based on a 4-layer reference model. Okay, that's application, transport, internet, and network interface layer. All protocols that belong to the TCP/IP protocol suite are located in the top 3 layers of the model. So any protocol that you know, okay, most of them, okay, they belong to the TCP/IP suite, and therefore it belongs to the TCP/IP model. Okay, but even though all the protocols belong to the TCP/IP model, people always use OSI model as a reference point. Okay, that's because OSI model is a much better model than the TCP/IP model. But you need to know about TCP/IP model as well, because that is what is being used. Okay, it's easy to remember because the application, presentation, and session, these 3 layers, it has been boiled down to a single layer called application. That's the reason why I said that application, presentation, and session layer comes under the system side. Okay, system. There you go. Okay. So these 3 layers come under the system side, and that's the same reason why in TCP/IP model these 3 layers has been boiled down to a single layer, that is the application layer. Okay, now if you think about it, the data link layer, that is the MAC address. Okay, the MAC address is a part of the NIC, right? NIC is a network interface card, and that's the same reason why TCP/IP has boiled down these 2 layers into a single layer called network interface layer. These 2 layers, they remain the same. The transport layer becomes the transport layer. Network layer it is written as internet layer, and it is correct. It is correct. Okay. But the thing is that I have seen, for example, okay, I have seen the transport layer, written down as host-to-host transport layer. Okay, host-to-host. Host-to-host transport layer, and network layer written as network layer written as internet layer. Okay, so the main thing is that you need to know what these are, and that's enough. Okay, all the functions that I had talked before, it applies to the TCP/IP model as well. Okay, thank you for listening.